Welcome student to the another lecture of alcohols, phenols and ether. This is lecture number 6. We already completed preparation of alcohol and phenol, and today we'll be starting with the chemical properties of alcohol and phenol. In that, the first one, we are going to do the lab test of alcohol and phenols. In that, first we are going to do litmus test for alcohol and phenol. Okay, for example, litmus paper, right? A red litmus paper, blue litmus paper. Okay, suppose I say I have red litmus and I put this red litmus in alcohol because we are doing the test for alcohol and phenol. So I took a red litmus, I put this in alcohol, right? And what result I find? The red litmus remain as red litmus only. Means there is no change in the color of a litmus paper. Okay, suppose this is the result what we have. Then what I will say is it acidic or basic? Since it have not shown any change in the color, I will say it is neither acidic nor basic. That means it is neutral, right? Suppose instead of red litmus I take blue litmus, and again I took this blue litmus, I put in alcohol. The result was found to be same in both the cases. That means alcohol is neutral in nature as far as litmus test is concerned. So I'm writing the result, that is alcohol is neutral, and this result is given by which test? Litmus test, right? Okay, now next I take a phenol. I take a phenol, right? In this phenol, suppose I add red litmus. What I add? Red litmus. Okay, what I find? No change in color, no change in color. That means what? If it does not show, see, understand student, when red litmus turns blue, right, then it suppose I am taking red litmus and it turns blue, and if it does not, if it turns blue, then I will say it is what? It is blue is basic, right? When red turns to blue, it will say basic, but it does not change in any color, so according to that I will say it is not basic, right? So it's not a basic one. Understand? First understand this and then you come on this part. If a red litmus turns blue, okay, I will say it is basic in nature. When blue litmus turns red, it is acidic in nature. When there is no change in color, then according to that it is neutral. So when phenol, I add red litmus and I find that red litmus remain red, that means no change in color, then according to that it is not, what I can say, it not turns blue, means it is not basic. Okay, so according to this it is neutral. I will say no change. Okay, right? But suppose I take blue litmus, I put this in phenol, and then the litmus color changes and it becomes red in color, right? Blue litmus changes color to red. I can say it is acidic, right? So phenol, when litmus test is concerned, blue litmus turns red, That means phenol is acidic in nature. Phenol is acidic in nature. I hope this is clear. So phenol is acidic in nature by which test? Litmus test. Alcohol is neutral by nature by which test? Litmus test. So the bottom line is this. Okay. Now, next is, this was with acid. Okay. I mean litmus test. Next is reaction with base. Reaction with base. Okay. Now, suppose I take phenol, and phenol I write AROH. Phenol. This is what? Phenol. I take a phenol and I treat this. Actually, one thing, student, phenol is acidic, but this is strong acid or weak acid? Phenol is found to be acidic in nature, and this is weak acid. Remember this. This is weak acid. Okay. So when acid is there, obviously it is going to react with base, right? So I take a phenol, I treat this with sodium bicarbonate, NaHCO3. This is base, and this is a weak base, right? This is a weak acid, this is a weak base. Okay. Will they react? The answer is no. No reaction take place. Because since this is weak acid, this is weak base, they do not react with each other. In short, phenol do not react with weak base. But if I take this phenol and I treat this with a strong base such as NaOH. NaOH is a strong base, student. Okay, then what will happen? They will react, and if they react, understand this is acid. Any acid furnish H plus. You know HCl is acid. Why it is acid? Because it gives you H plus. Okay. Arrhenius theory of acid and bases says that if any species gives H plus, they are said to be acid. If any species gives OH minus, it is a base. If it is an acid, it is going to give H. So this H and this OH, base gives OH. So it will form what? Water, and this will become like this. I'm writing in this form of structure. We have studied this. This is phenoxide. If I right, and this Na plus, this is sodium phenoxide plus H2O. Right? Okay, you understood this? That means this phenoxide is formed when phenol reacts with a strong base. And to this phenoxide, if I add, suppose I add acid to this. I'm writing in the next page. Suppose to this phenoxide ion, I treat this with HCl, right? Means this is actually a salt. Salt reacts with a strong acid. Okay, what is going to form? Again, understand this, student. This Na will combine with Cl, and this H is going to come over here. So it will become again phenol. It becomes what? Phenol again, right? And it will form NaCl. Got that? And understand the sodium phenoxide which was formed will be water soluble, and here this will be regenerated. Clear? Understood? Simple. Now, moving to we studied the reaction of phenol with base. Now, when I say if I react with alcohol, suppose I take alcohol and I react with this with some base like NaOH or NaHCO3, it will react? Answer is no. It is not going to react with either NaOH nor NaHCO3 because this alcohol is actually according to our study till this point, I can say this is neutral. Since it is neutral, it is not going to react with base, either not going to react with weak base, that is sodium bicarbonate. Okay, so it will show no reaction, student, no reaction. But then reaction was carried out by using some metal like sodium. Then in that case it was found reaction take place. How the reaction take place? This Na replaces this hydrogen, right? So what is formed? RO minus. This is phenoxide ion, right? This is phenoxide ion. Alkoxide, because it's alkyl group, right? It's not a phenyl, it's alkyl. So this is alkoxide, right? But sodium combined with this, so it will form sodium alkoxide. This is sodium alkoxide, and hydrogen comes out. See, Na comes in, H goes out. So when H goes out, it will be only H, but H can't remain like H because hydrogen is stable in H2 form. So I have to take 2. For that I need 2 hydrogen. So I will write here 2. So that for that I need 2 sodium, and here also 2. That is the balancing, simple. So what this reaction proves? See, this reaction take place, but it is proving something. It is proving that even alcohol is slightly acidic in nature. Slightly acidic in nature, and this can be proved only when alcohol reacts with a very strong electropositive metal like sodium and all. In that case, it shows some of the acidic character, which is very slightly in nature. Okay, student, understand this much? Right. Now, here the liberation of hydrogen take place. So I show it by the arrow. Okay. Now, next is characteristic test for phenol. Some characteristic test for phenol. Okay. Now, suppose I take phenol, right? I'd show it like this, phenol, and I treat this with neutral ferric chloride. When I say ferric, FeCl3, Fe is plus 3 charge, FeCl3. Okay, then what happened? Understand, student. Here, this phenol, if it is showing acidic, that means it is going to give H, right? This H which comes out combines with chlorine. So since 3 chlorine is here, we need 3H. So I write like this. So this 3H combines with 3 chlorine to form what? HCl, right? And 3. Now see, here chlorine goes away, ArO is left, right? And Ar, suppose I write like this, ArO minus. So that means it is 1 negative charge, right? So I required 3. So I will write like this, 3Fe, right? And this is a test. So how I'll identify when I react with phenol to FeCl3? Because if it is I have to identify the test for phenol, means I have to prove whether this is phenol. So how can I identify? I can identify only if it shows color. Which color? It shows some deep color like purple or green in color or violet. Understand, student, what I mean to say? Suppose I have some liquid. I don't know whether this is phenol or not. Okay, what I do? I add FeCl3. As soon as I add this, okay, and if the color of the solution changes, like deep color of purple, green or violet, I will report that this compound is what? Phenol. So this is one of the tests for phenol, right? Same way, there is a test for alcohol. What is that test? We have already studied this test. Test for alcohol, right? And this test is called as Lucas test. Lucas test. Student, this we have studied in great depth in the last chapter. Okay, you might, if you have seen the lectures, you can easily recollect that. If not, go and watch it. Here, I'll be explaining that, but not in great detail, because I have done it in the last chapter. Okay, understand. What is this Lucas test? Alcohol is treated with what? HCl in presence of ZnCl2, and it gives alkyl halide. That is what the test is. It gives what? Alkyl halide. For example, alkyl chloride, because here we use HCl and ZnCl2. So actually it gives alkyl chloride. This is nothing but alkyl chloride, right? Okay, now understand. If I take 1 degree alcohol, and if I treat this with HCl and zinc chloride, this is one. Second, if I take 2 degree alcohol and if I take 3 degree alcohol, actually this is a distinguished test to find whether the alcohol is 1 degree, 2 degree, 3 degree. If I take 3 degree alcohol and I put this Lucas reagent in that, the PPT will be formed, and that PPT form, actually not PPT, it shows what we call turbid color, turbidity, not PPT actually, it is turbidity. Okay, so here turbid solution is formed. I'm writing again. Turbid solution is obtained, and that too immediately, right? The process is very fast process, very immediate. As soon as I put HCl and zinc chloride, a turbid solution is obtained instantly. But if it is 2 degree alcohol, the turbid solution which is obtained, okay, here also we obtain turbid solution. Here turbid solution, but only after 5 minutes of putting the HCl and zinc chloride. So if it forms instantaneously, I will say it is what? 3 degree alcohol. But if the turbidity is formed after 5 minutes or after some time, I will say it is a 2 degree alcohol. If no turbidity is obtained, no turbid solution, then I will report it is 1 degree alcohol. Right, so this is one of the distinguished tests for alcohol. Okay, again I'm saying, suppose you give me some solution and you ask me, find this solution is 1 degree, 2 degree alcohol or 3 degree alcohol. So what I'm going to do, I'm going to put zinc chloride in that, and suppose turbidity is not formed at all after 10 minutes, 15 minutes also, I will report it as a 1 degree. But if turbidity is obtained after 5 minutes of adding Lucas reagent, I will report it is a 2 degree alcohol. But if it is obtained instantly after adding, I will report it is 3 degree alcohol. Right? So that was Lucas test. Okay. Now, actually student, this year, what till now I've taught, actually they have omitted. But actually not omitted, I'll say, they are set for self-study. But then also I taught you this. Okay, it will be your decision to how to study that. Right. Now, moving to the next part of the chapter, where we are going to do the reaction where the breaking of a bond, and this is very important. Here in this reaction, actually alcohol react, but when the reaction take place by breaking of this bond, okay, means in this case there will be breaking of a bond between oxygen and hydrogen. Understood? There are actually two types. A bond can break from here also between R, that is R is carbon and oxygen, or bond may break between oxygen and hydrogen. If bond break like this, it will form what? RO minus and H plus. It also will show acidic character of the alcohol. Okay, now student, we'll be doing some reaction where it will prove the acidic nature of alcohol. Right, now what we are going to do, we are going to react this. Suppose I took alcohol and I react this with water. Right, when we react with this water, the product form is RO minus, you know, because it's alkoxide ion, because this alcohol gives H, and this H plus will combine with water to form what? H3O plus. Right, but here I have put reversible sign. Why there's a reversible sign here? The reason is that this alkoxide is not stable. Why it is not stable? Because of plus I effect of R. We have studied this, student. Alkyl show positive inductive effect. So this R provides electron to this oxygen, right? So when this electron is provided to this oxygen, the charge on the oxygen increases. This negative charge make this unstable. This negative charge make this what? Unstable, because R is also provide oxygen electron to the oxygen, which make it unstable. Okay, so that's why it is unstable, and that's why the reaction moves backward. If you want that reaction move in the forward direction, okay, so what we do, as soon as this is formed, we remove water. This hydronium ion which is formed, we remove this. So when this is removed, the reaction will not go in the backward direction. Okay, this we can do, but this is actually unstable, so reaction is not going to proceed further in the forward direction. Okay, now this is actually ionization of alcohol. Next is ionization of phenol. Suppose I take phenol. I'll write here topic ionization of phenol. Okay, now suppose I take this phenol OH and I treat this with water again. In this case, what will form? It result in the formation of phenoxide ion plus H3O plus. But student, this phenoxide ion which is found is found to be stable. And why it is stable? Let's understand this. This is because of resonating structure. Even this we have studied in phenol, student, but then also I'm drawing it again. So this is oxygen, this is minus, right? Suppose this negative charge put this electron over here, so this bond will break and the negative charge comes on this, right? So what will be the resonating structure for this? Here there's a formation of this structure, double bond. The negative charge will come on this, there will be double bond, right? Same way, see, I've explained this in detail, student, right? Now here I'm just putting it a bit fast forward, right, because we have actually studied this. The negative charge which is here will come on this. How? I have to move this here. So when I move this, oxygen will like that, negative charge come on this. Okay, so this will come here, it make a double bond like this. This is a negative charge, and now the negative charge from here will come on this next resonating structure. So next resonating structure will be like this. Okay, see, this is negative, I have to make it positive, so the double bond will come over here, right? Okay, so to positive I have to put this electron over here. Understand, student? This is electron, this will first move over this, so this become negative, this will become positive, positive negative will make a double bond, this bond is already here, right? Again, I have to convert this negative, right? So this has to move here, so when this moves here, again we get O minus, right? This negative positive will form a double bond and we get like this. So because of this resonating structure, phenoxide becomes stable, right? This phenoxide become stable. Understood? Simple, student? Clear? So this is the reaction where the ionization of phenol and alcohol take place. Okay, only the thing is that the conjugate, this is acid, the conjugate base is phenoxide. Understand? This is acidic, this is basic, conjugate base is found to be more stable in phenol, whereas conjugate base in alcohol is found to be less stable, and that's why this happened, right? Okay, now moving to the next reaction, actually where this part take place of esterification. Okay, so but I think time is over, students, so we'll stop for today and we'll continue in next lecture by the process of esterification, right? So what we did today, actually we have started with the chemical reaction of alcohol and phenol. We have done the lab test of alcohol and phenol, right? In that, first we did litmus test, okay, for alcohol and phenol both. What we did, we take a red litmus and blue litmus both, we put that in alcohol. What was the result? It found that neither red becomes blue nor blue becomes red, proving that it is neutral in nature. So litmus proves that alcohol is neutral. But when we take off phenol, we put both blue and red litmus paper in phenol. What we found that in red litmus paper there was no change, but in blue litmus paper it turns red. So when blue turns red, it proves that it is acidic in nature. But the nature of phenol is found to be weak acidic, so it's a weak acid. Okay, but since it is acid, it can react with the base, so we tried the phenol to react with the base. What do? We react with the base. In that, the reaction we did was, phenol was first treated with a weak base, but then it was found that because phenol is a weak acid, it will not react with the weak base, so no reaction was obtained. But when the phenol was treated with a strong base like NaOH, it formed sodium phenoxide. It formed what? Sodium phenoxide. That proves that phenol is actually acidic in nature. Okay. Now, then we tried the reaction by using alcohol also. When we react with alcohol with base like strong base like NaOH or weak base like sodium bicarbonate, there was no reaction, neither with weak or even with a strong base. Okay, but when this phenol was treated with an active metal like sodium, it was found that this alcohol gives H plus, okay, or hydrogen gas was liberated, proving that this act as acidic in the presence of metal like sodium. So even it proves even alcohol is slightly acidic in nature, right? That was the bottom line. Now we did some tests for phenol. right? Means suppose I give you some solution, we are not aware whether this is alcohol or phenol. So how I'm going to identify whether the given solution is alcohol, phenol, or any other thing? Okay, so test for phenol. You take that solution, whatever is provided to you, put FeCl3 in that. As soon as you put the FeCl3 in that, some dark color purple solution or green solution or violet solution is obtained, will report that the given solution is phenol, right? Now, if it does not shows, then we'll say obviously it is alcohol. Okay, now suppose there's alcohol, but a person wants to know whether it's 1 degree alcohol, 2 degree alcohol, or 3 degree alcohol. So what in that case we are going to do? In that case, we are going to add HCl and zinc chloride. This is Lucas reagent, and this test is called as Lucas test. If the solution turns turbid immediately, I will say it is 3 degree alcohol. If the turbidity is obtained after 5 minutes of adding Lucas reagent, it will be 2 degree alcohol. But if it is not obtained at all, turbidity is not obtained at all, I'll report it is 1 degree alcohol. Okay, after that we done the reaction of alcohol with water. So when we do the reaction of alcohol with water, and mind this is a test where the H of alcohol is removed. So this H combines with water to form hydronium ion and alkoxide ion. This alkoxide ion which is formed is unstable. Why this is unstable? Because the alkyl group is putting, or I say it's forcing, its bonded pair of electron to the orbital of oxygen. As it is forcing, this negative charge will on the oxygen will increase, and this is going to increase the electron density on the oxygen, which will make it unstable. But when we take a phenol, we perform the same reaction, we get phenoxide ion. In this case, the electron density which is at oxygen, actually it is resonated throughout the ring, and that's why this was found to be more stable. Okay student, so that was what we have learned today. In next lecture we'll continue this part only, where the breaking of hydrogen will take place from alcohol. Right, we are left with few more reaction. Okay, and that we'll be doing in the next lecture. So for today we stop. Thanks for watching.